need a, oh, before we go there, any questions on any homework or anything else before we get going on the quiz? Yes?
Could you like do one Euler problem with a slope? Like,
Euler problem. Sure.
Yeah, with like how you show it on the graph.
How you show it on
Like
the
how you do the
graph.
slope on the, unless it's not going to be quiz.
So let's say we had some differential equation. How about that? And we say, okay, we're going to start at 0, 0. So put a little table here. So x was 0 and y was 0. Oh, dy dx for m, the slope is 0. And if I model this with a straight line, that would be y equals mx plus b. So we have 0 equals 0 plus b. So of course, b is equal to 0. So that would be the first easy point. So the next point, we're going to increment x. Or we could decrement it, we go in the other direction. So let's say we're going to do this real sloppy, right? In a computer, you might want to do it like 0.00001. We'll just do it 1 because it'll make the numbers come out easy. So y is, that's what we want to figure out, isn't it? Yeah. So we use our equation, from the last iteration. So y equals 0 plus, is that right? No, I may be missing something. Not doing things in the right order. I guess what I want to do is I want to find, no. Here, my slope, so my next point has to be here. Why am I not getting the right? Oh, my y is 0. Yeah. So I have y equals 0 plus 0. So my y is 0. Oh. Well, I picked the wrong differential equation because the solution you can get going to 0 is going to go like that. So let's do this. That would be a little smarter. Okay, so differential equation is x squared y plus 1. Right. So now this is my first point. My slope here is now 1. So y equals x plus b at 0, 0 means b is 0. Okay, that's good. So my next point, this is my little 0 plus delta x, which again I'm just going to make 1. So then I plug that into that, equation, y equals x plus 0, and I get my y is now 1. So now, my dy dx is now 1 squared times 1 plus 1 is 2. And now I repeat the whole thing, so I get y equals 2x plus b. The point is 0, 1. So 1 equals 2 plus b, so b is now equal to negative 1. This is kind of sloppy, this equation is doing weird stuff. But you would just repeat that over and over and over again. Now, you wouldn't see these kind of, well, I don't know, you wouldn't see this kind of wide swing if you use a very small, like even just 0.1 delta x.
Shouldn't b be positive 1? Because it's 1 equals 2 times 0 plus b, isn't it?
So b equals -1.
But, okay, never mind. Well, but you're at 1 equals 2, wait, no, 1 equals 2 times 0 plus b, so then 1 equals b, right? Because you're plugging in 0 for x.
So I'm here, and now my x is 1, because I just increment it.
Right.
From my previous equation was y equals x plus b, which is 0. So my y is 1. So my second point is 1, 1. Is that what I did wrong?
Yeah, you wrote 0, 1.
Oh, so 1 equals 2 plus b. So b equals -1.
Yeah. Because you're at 0, 1, so I thought. Yeah.
Oh, well, yeah, you're right.
And you plugged in 1, but you wrote 0, so.
Yes.
Okay.
I wrote the wrong thing. Okay. Does that help? It's kind of monotonous, you know, find the linear equations, the estimate, increment, do it again. This is why I kind of emphasize the idea of doing it with a computer.
So you like draw a line on the slope if it's like 1, you would just like have it rising.
I'm sorry?
If it's like, since it's 1 for y, it would just be straight. Okay.
So the next slope is 1, and the slope after that is going to be 2. So the next one is going to be heading off in this direction. It's going to, you know. I mean, again, it's kind of awkward to do it with a big delta x. You know, it's not accurate enough to model this correctly. I'm just trying to get the idea here. So, work, and again, this is a, y double prime minus y equals sine of x. Okay. So y equals 0. Y prime is 0. Y double prime is 0. So let's see. 0 minus 0 equals sine of x. And didn't work. Okay. Y equals cosine of x. Y prime equals negative sine of x. Y double prime equals negative cosine of x. So negative cosine of x minus cosine of x equals sine of x. Or equals sine of x. No. Y equals negative cosine of x over 2. Y prime equals sine of x over 2. Y double prime equals cosine of x over 2. So we have cosine of x over 2 minus cosine of x over 2 equals sine of x. Cosine of x equals sine of x. No, that's not either. Okay, y equals minus sine of x over 2. Y prime equals negative cosine of x over 2. Y double prime equals negative sine of x. Oh, positive sine of x over 2. So you sine of x over 2 minus sine of x over 2 equals sine of x. Oh look, sine of x equals sine of x. Verify.
So if we didn't show our work, but we
Then
got
I
the
can't
right,
look at it.
no, but we got the right answer.
But you got the right answer.
Will we still get full credit?
Yeah.
I
Didn't say show your work.
Oh, no.
Let me just so we don't go someplace funny. You didn't cheat, right? You didn't look at someone else's paper, right?
No.
Well, then.
And if I did, I wouldn't tell you. I was kidding.
Wait, so
Yeah.
if we accidentally switched the y double prime and the y in the original equation, how many points?
Did you show your work?
Yeah,
Well, then I'll look at it and make some kind of evaluation.
okay. And like I even.
I mean, you know, I'm pretty sympathetic to stupid errors you make. I
and
can't
I'm
give
very,
you
very
full
stupid,
credit,
so I
but
appreciate it.
you know, there's a difference between making a stupid little error in computation during a test and not knowing. Okay, was there another question?
Yeah,
3?
4, 5, 6.
6 was extra credit, right?
Yeah.
Yes, it was.
No, it wasn't. You failed.
Okay, so, boy, this looks like a question somebody asked right before class. How convenient. So there's my chart. This was just, you know, to help you. So the equation is dy dx equals x over 2 plus e to the x. And we say y sub 0 equals 1. So x0, y1. And I want delta x to be 0.5. So I'm going to look at 0.5, 1.0, 1.5. And how many did I ask? Oh, just 3. So we really only need to go this far. Okay. So let's see. X is 0, y is 1. What's dy dx? 1. 0 plus 1. Oh, it's 1. Okay, so the linear approximation, y equals mx plus b, becomes y equals x plus b at the only point we have, which is 1 equals 0 plus b, so b is 1. Okay. So now we're going to use that equation, y equals x plus 1, to get the next point. So we plug in x 0.5, y equals 0.5 plus 1, and I'm going to switch over to fractions. 3/2. Okay. So dy dx is now 3/4 plus
Square root e.
Wait a minute. Yeah, square root of e.
No, you mean 1/2.
Wait, hold on. What am I doing here? I'm gonna, this is 1.5, right?
Mm-hmm.
So 0.5, well, 1/2 over 2 plus e to the 1/2 is 1/4 plus the square root of e, right? Hmm?
Yeah.
Just write that in there. 1/4 plus square root of e. I mean, we don't have to be exact, we're just approximating, but. Okay, so now my linear approximation, y equals 1/4 plus square root of e x plus b. And I have this 0.5, 1.5. So 1.5, 1/4 plus square root of e is 1.5 plus b, so b is just 1.5 minus this. 1.5 times 1 minus a quarter, 3/4 minus the square root of e. And we're almost there. Because now we just plug in for y equals 1/4 plus square root of e x plus 1.5 3/4 minus square root of e. If you did this with a calculator and gave me a couple decimal points, or even one decimal point, that would be fine. Okay, so now we just plug in 1, and this becomes 1/4 plus square root of e. It's 1.5 3/4 minus square root of e. I can simplify that, put it in here, and that's kind of what I'm looking for. You didn't need to fill in these, right? That's to go to the next step. So if you did, it doesn't hurt. Notice I said filling in the chart may help. Okay. Other questions about that, or other questions?
Number 4.
Find the solution. Find the solution to y prime minus 4y equals 0. So with y sub 1 equals 2, so you could do it the same way we did that problem earlier. Say r minus 4 equals 0. So r equals 4. So y of x would be some constant e to the 4x. And plugging this in, we get 2 equals a e to the 4th. So a equals 2e to the minus 4. And that means that y of x equals 2e to the minus 4 e to the 4x. Or if you like, 2e to the 4x minus, say, 4 times x minus 1.
Since you didn't ask for an exact answer if we evaluated e to the 4th.
Yeah, foolish me. You mean if you put if you figured out what e to the minus 4 was? Okay, any other questions?
The one after that one too.
It's as if
Can
we
you
went
just do
the
the
whole
whole
quiz.
Apparently. Alright, so number 5. This is right out of what we did. Okay, so you want to find dy dx equals x over y minus cosine of y. I don't really fiddle around here. I just tell you, oh, and y sub 0 equals 4. Okay. Implicit or explicit, well, you can probably guess. So we have y minus cosine y dy equals x dx. We're going to integrate. That's the separation of variables method. And what do we get? We get y squared over 2 minus sine of y equals x squared over 2. That's an
Plus
implicit
C.
solution.
Plus C.
Let's see.
Oh, yeah, plus C.
Oh, yeah.
That's an implicit solution. And we want to find out what C is. So 4 squared over 2 minus sine of 4 equals C.
A.
Not hard, were they? Okay.
And you didn't ask for an exact answer on that one either.
Well, yeah, so this is 8 minus sine of 4, so if you gave me some approximation to that,
Yeah.
I'm guessing you're probably going to put exact answer on every single problem.
You think I'm a mean person? This is a better answer. It's an exact answer, but if I didn't say, give me an exact, I didn't.
Would it
We
be,
stumped.
would it,
What, yes?
would it be wrote that and then like next to it we wrote something completely wrong? Like
Like I did one.
and then I wrote like, and I did this whole other problem.
So let's see, we do this, and then we go y equals crap.
Yeah,
Right?
Like if there's
And I look at those and I go, and you say, this is the right answer, right? So I'll go, well, you know how to do it. Why? What did you do? What did you know? You might not get 100% credit, but if you did it all right and you got the right answer and then you did something else, I mean, if you take this to its logical conclusion, its logical extreme, let's say we're in first grade and I say 1 plus 3 equals, and you write down, well, let's see, 4, 7, 9, 1, you see, you can't just say, oh, you got the right answer in there somewhere. I can't do that, but I'm looking to see if you knew how to do it. That's what I'm looking for.
The correct
So-
answer to that is x element of n. Because the answer is contained in that set.
You are welcome to ask for recommendation to apply as a math major anywhere you like. That will work. Okay, did we miss anything?
Extra credit?
And number one, never did that happen.
Like Kelly's gonna be number one. This is a graph.
So the first thing you want to do for the extra credit, you'll notice I didn't say find a solution, right? I just said write the differential equation. So what I'm going to do here is, everyone know what this is?
Looks like an ellipse.
This is a set of ellipses. I guess they're actually kind of, the y is the major axis, right?
D on 7.
So what would orthogonal kind of look like? Kind of be something like, I mean, this is in there and this is in there, but I don't really know what, goes in there. Okay, so implicit differentiation, this is x plus 2y dy dx equals 0. So dy dx equals minus x over 2y.
Now I got it.
So that's the slope along here. So we want a function where dy dx is the negative reciprocal of this, 2y over x.
Whoops.
Which I guess you could try and solve that if you wanted. Wasn't? Oh, yeah. So if you said
Separate
dy
variables.
over 2y equals dx over x, so we would have 1/2 log of y equals log of x.
Plus c.
So you can almost, I don't really want
You
to
got
think
the
about
c.
this. Say y equals plus or minus e to the 2 log of x.
Plus C. place.
Yeah, I don't know.
It
It's like,
has to be next to the ln(x).
oh. You're right. Yeah, because really it's e to the c, some constant, multiplying it by. So we could just say c, where c is, c be 0? Sure, y equals 0, that's a solution, right? That's this. So for all c. Oh, that was fun. I had fun. Okay. I knew this would happen. We have half an hour left. And it wouldn't be very sporting of me to give you new stuff to learn for the exam. However, I came up with a brilliant idea. I think it's brilliant. So, first a little background. Circa, 1995 or so, someone looked at the curriculum for calculus and said, there's something we've been doing for 100 years that's kind of stupid. What they used to do in calculus is the first subject they would cover is not just what a limit is, but the exact mathematical definition of a limit and how you prove it. Now, as I've learned, some of you may have come across what's known as a delta epsilon proof.
Yes.
Anyone seen that?
Yes, I proved it for basic polynomial. It was a pain in the ass.
Okay. So, for those of you who haven't seen it, I'm going to show it to you. What used to happen is, the reason they got rid of it, what used to happen is calculus students, they came from like high school maybe, or maybe they were in high school, and they saw this thing and they thought, oh, my head hurts. I don't know what he's talking about. What the heck is that about?
It works. That's as far as you need to go.
And and they eliminated it from the curriculum with this kind of touchy-feely kind of a limit is when you get close. But I want to just spend a few minutes, just in case, you may forget this and never care. You may go on to math and you'll go, oh, I remember that. That was good. I just want to talk about it a little. And then when I'm done, you can go. What's that?
Burn his house down.
And if you get a headache halfway through, you can go to it. This is critical. But I think this is really cool. So this is the definition. The limit as x. Now we're not covering one-sided limits. We're not covering limits to infinity, although they'll all follow from this definition. If f of x, the limit as x approaches c of f of x equals L, and I don't know why they say if and only if. This is a definition, but if and only if, well, they're just saying the same thing. For each, and now we use the Greek epsilon e, which in mathematics usually means some very, very small quantity, but we're not really saying that. But for each kind of small quantity e greater than 0, if for each epsilon there exists a delta, delta, that's the lowercase delta, such that if the absolute value of x minus c is between 0 and delta, then the absolute value of the function minus the limit is less than epsilon. Now this is quite obtuse. What the heck does this mean? So we're gonna look at a little graphic here that is gonna help a little. I'm going to digress for a second. I want to talk about something that I learned in 7th grade. Now, in 7th grade, we had a really cool math teacher. I don't know why he wasn't, I don't think he could do calculus, but he knew some basic math, and he asked us this question. He says, I have a line segment. It's got 2 endpoints. Right? He says, I take away this point. Right? He says, what's the next point over?
Epsilon over.
No. What's the next one after this? What's the next one? The answer isn't 1. It's like saying, what's the greatest number, say, x less than 1? What's the greatest number x less than 1?
Greatest integer or greatest number?
Greatest real number. So
0.9 repeating.
9.
No, right.
You could keep writing those. If you write them infinitely,
1 minus.
you've got 1, so there really isn't such a thing, right? But you could talk about, like, say, all the points in the line, from some point over, excluding this. You could call that a set, even though you can't find.
It'd be an open-ended set.
Yeah, the open-ended set. Okay, I just wanted to mention that as a precursor. So we have some function, and there's some value, there's a c, that's this number c we're approaching, and it has some value there. This might not be continuous. Point might be up there, or might be up at infinity or something weird, or it might, it doesn't matter really. We don't care about this. We don't care what f of c is. We care what's going on around it. A limit has to do with what's going on around that point as we approach it. So what this definition says is that if you give me I have to think a little. If you give me if you give me some constraints, right, around here. In other words, if you give me some constraints around this limit, notice we have a limit at this point. This is not a definition to find a limit. It says you have a limit, you think it's a limit, now you prove it's the limit. You have some number. So we have L, and we're looking outside, a little outside of L. Look at L plus epsilon, this interval L minus epsilon. We're looking around. You give me an epsilon, I bracket it. And if for every epsilon that you give me around it, no matter how small it gets, I can give you a delta. So we have this interval c minus delta to c plus delta. If whenever you give me an epsilon, I can give you a delta. And within that interval, this function, except at that point, is within those epsilons, then it's a limit. That's the limit. Now that's a little vague and fuzzy. I'm drawing kind of big limits here, and to get within it, I only need, assuming this was increasing, let's say, my delta can be pretty big. But I didn't ask for a specific epsilon. I asked for every epsilon. So you can think of this as kind of a collapsing thing. As this collapses, my delta probably collapses. But I still, for any epsilon, I can find that delta. So what's going to happen is, as I get smaller and smaller and closer to this, then there's some window within which whatever epsilon I pick, that's going to be the case. So it kind of goes down and down and down and down, down, but it just doesn't ever get there. It's kind of like if you were trying to find the next point, you can kind of go down and down and down and down and down, but you can never get there. Okay, so that's kind of the idea. You're kind of squeezing in on this point, but you don't care what happens when you get there. Turns out for a nice, smooth, continuous function, that always is the limit, but there are plenty of functions where it's not. So,
This is the definition of a two-sided limit.
this is the definition of a two-sided limit. That's true. There's a
Remove
slightly
the
different.
absolute value and you get the,
There's a slightly different version for a one-sided limit, and obviously it's going to look a little differently if we're going to try and find a limit as we get to infinity. But to cover those, I'd have to be teaching you an analysis class, and we're not going to do that.
okay, Google searcher, it helped. That helped me.
Thank you. Okay, so with that in mind, I'm just going to demonstrate as clearly as I can a very, very simple delta epsilon proof. Just so if you've never seen one, I know you have, Daniel. Just so if you've never seen one, you can see how it works. The funny thing about delta epsilon proofs is when you're trying to figure it out, you work backwards. But then to do the proof, you kind of have to go forwards. So I'm gonna show you how it works going forwards. You might say, well, you must have done something to figure that out. I'll say, yes, that's true.
You did mathematics.
Okay, so we're going to look at what the limit as x approaches 2 of 2x minus 1. Well, that's obviously going to be 3. We want to do a delta epsilon proof. So, first of all, first step in our proof is let epsilon, I want that to look like the inclusion. Let epsilon be greater than 0. Okay? And what we want to show is that there's a delta greater than 0 such that if x minus 2, the absolute value of x minus 2, in other words, the distance this is an interval around 2. I guess you could think of this as 2, and then this is the interval around it. If that's less than delta, then the distance of our function at that point from the limit, this is the distance from, this is the limit, this is our function, that distance has to be less than epsilon. So if we can find this guy, where if this is true, then this is true, then we're done. So here's the hand wave, here's the part where, how did I figure that out? Well, it's not not that hard to see, but we're not going to do it. I'm going to set delta equal to epsilon over 2. So basically I'm saying if 0 is less than this distance, if this distance is greater than 0, but less than epsilon over 2, what can I conclude? Well, I can conclude that 2x minus 2 is less than epsilon. I'm sorry, less than 4, right? But that means 2x minus 3 minus 1 minus 3 is less than epsilon. So by merely picking the right delta, I've shown that this condition is satisfied and the proof is complete. Now, this is a really easy, trivial one. Sometimes you have to be more creative in picking epsilon, in picking delta. Most of the time, delta has to depend on epsilon. So, again, there's a whole mechanics of dealing with absolute values, and sometimes you use triangle inequalities and other things from mathematics, but that's really it. That's it. I just wanted to show you guys that. If you find that really, really obtuse or boring, you're normal. And if you find it exciting, you can look forward to enjoyable careers in mathematics. All right, good luck. Do see if, do check out the review sheet, do bring in questions. We'll review on Thursday, and then good luck on the final too.